All right, so at the risk of giving away the keys to the castle, I wanted to demonstrate how the software industry flattened, right? Much like the rest of the world is flattening, all the pieces are flattening. Um, so the way you develop software, large projects, not small projects. There's a lot of small projects you can do kind of mostly by yourself, but not really, not really. It seems that way. You start importing other people's code real quick, and there's great code out there, and there's no reason not to do that. But you didn't write that. Just, just saying. Most software projects that I've seen, the software teams write about 1% of the code that gets released. So literally 99% of the code they didn't write. They could write 10 million lines. Don't care. There's usually, a lot more lines than that going on. Some of these Java projects in particular have billions and billions and billions of lines of code that are in the runtime that nobody on that project wrote. Nothing wrong with that. Nothing wrong with that. But for large projects, we have more than one person. The problem is a problem of integration. Okay? So person A and person B are writing code. And in order for that to be in an application, those two pieces of code have to not conflict. And more than that, they have to cooperate, right? So if they're not directly cooperating, they at least have to cooperate further down the chain. In other words, whatever data this thing's dealing with has to get transformed into something this thing can deal with at some point. Otherwise, it's code you didn't need and can remove. So because those people working on these different parts have different approaches, and because there's different ways of doing things, and there's a lot of equally valid and equally useful and equally efficient ways of doing things. And because perspective matters, and they probably have different perspective because they're different people, so that sort of has to be the thing. There's an integration that has to be done, right? There's a consolidation, there's a cooperation that has to occur. Now, when you're dealing with two people, it's not so hard. When you start dealing with 5 people, it gets really hard. And when you start dealing with multiple teams, it gets even harder. So what happened in the early days of software engineering, say in the 70s and 80s, is that these groups would coordinate together and talk to each other, over email and whatnot, and sort of figure it out and make it work. And then a bunch of tools were designed in C++, which is a very horrible language. It's not as horrible as Java, but it might be the second most horrible language. So they do like private functions and things like that. And then, of course, that creates problems because then you, as the person getting the function, can't see what's going on, and you have to trust the output. And when the output's wrong, it looks like your code has a bug and not theirs, but it could be theirs. So there's all kinds of problems that occur as the result of having to cooperate with multiple people. Now, where and how you solve that has changed. It used to be that those problems were solved at compile time. And typically in old software shops, right up until the late 90s, early 2000s, and I worked in some of those, but that was all the same model that had been done for decades at that point. You would have a lot more collaboration behind the scenes and a lot less involvement in things like meetings, at least in the coding phase. The old model was 80% design, 20% coding. Now, the new model is 100% coding and no design ever, roughly speaking. That's not a little unfair, by the way. That's actually what's happening all over the place. It's usually what I'm running to fix, right? So even in the, quote, best designed, they didn't spend any time on design at all. There was always a guy who did the build. Now, the build is the big compile at the end. And you can say, oh, no, we don't have to do that because we have rapid application development, and Java is compiles at runtime, and bytecode compile and all this garbage. It's all garbage, by the way. I mean that literally, except for certain specific cases. But for production software, RAD's no good. It wasn't designed for that, by the way. It was never intended to go into production. Zero rapid application development was designed to go in production. It was designed for prototyping. That's it. It was designed for prototyping to make sure concepts worked. It was never designed to be run. bytecode compiles garbage because it doesn't work. It's highly inefficient, creates bugs all over the place. Any Java application will show you that. Like, just work on a Java project, see all the bugs. You can get around most of them just by adding more memory, but you're just hiding them at that point. So what happened was, these people who knew integration would do the integration. They'd do the compile, and they'd get all the code to talk and all the functions to talk, and they'd submit all the changes, and the engineers who did the original code would go back and look at, oh, okay, he made these changes, and sometimes they'd yell at the guy, and he'd be like, yeah, well, I had to make those changes. And he'd do his work once a month. Not entirely, but generally once a month. Of course, he'd work all day, or 3 straight days trying to get the compile to work. They did it compile time. And then they'd go through a testing phase, and they'd go through a release phase, whatever. And then we did away with all that because of rapid application development and misapplication of it, because new programming languages, most of which are junk, by the way, complete trash, complete garbage, no new concepts, no new anything, completely unnecessary. There are a few exceptions, but given the number of languages there are, my goodness, there are a lot of programming languages now. And Java is a complete nightmare because Java was designed for embedded systems, which is just hysterical because it's a pig and uses up way too much memory. But it's not used that way, which is one of the reasons why Java is terrible, because it's not being used for the thing it was designed for. It's actually really important. We started to compress this cycle because we were running into problems. And the development teams were complaining that it was taking too long to find problems in production. Now, if you have a proper release cycle and a proper integration at compile time, and you find a problem in production, you have terrible engineers. You should fire them. I'm not joking. You really should fire them. There's a problem. They're not good, right? Like, good engineers don't have that problem ever, right? It doesn't happen. Those problems are caught in QA and fixed there. Period. End of statement. Full stop. When there's a problem in production, a good engineer will know immediately whether or not it's data or code, because a lot of production problems are data. Or if there's a fundamental difference in how the systems operate, although usually that's not a software architect, that's a systems architect who knows that piece. Because there's only 3 possibilities: bad data, bad code, bad infrastructure. That's all you got. It's only 3 buckets. As you compress these things down under the theory that, well, we'll have fewer bugs and we'll be able to develop faster if we develop the software closer to what we release, okay? This is false. It is mathematically provably false, by the way. So anybody who took a CS course, you should know better. This is in their texts. I know. I've read them. It's there. Also, you can work it out on your fingers by yourself. Actually, it's not hard to figure this out. It's just a bad idea, right? The shorter the release cycle, the quicker you can release, the smaller changes you'll make, but the more bugs will appear, because more releases always correlates with more bugs. Period. End of statement. You want fewer bugs, you need fewer releases. It's just that simple. There's lots of very good reasons for this. They have to do with software velocity, how teams work, integration, level of change, rate of change. There's all kinds of weird factors. They all work against fast release cycle, by the way, and frequent release cycle. So you get these rapid application design languages, these RAD languages, rapid application development languages. And now all of a sudden you can code something that's, good enough for production in small environment, or so it seems. And so you do that. And then you have scaling problems. So you rewrite the application in that language and, maybe you can get by. But really what you're doing is you're adding a huge number of software engineers to something that doesn't need a huge number of software engineers because you're getting around limitations in the language and the infrastructure rather than architecting or designing the code correctly so you never run into those problems. So you've moved where the problem is. The other thing you've done is that you've compressed the release cycle down so that your software as it's coded is assumed to be correct. So you release it immediately to production or quicker to production with less testing, because the sooner it's in production, the sooner you're going to find the production bugs. That's technically correct. Unfortunately, you've also created at least 3 or 4 orders of magnitude more bugs than you would with a better design system. So why does this happen? Well, it happens because with modern version control systems, not the older ones, but the modern version control systems, integration of code level changes is instant. The problem is that that only finds one particular set of bugs or problems with the software incompatibilities in groups and functions and things that are coded. It doesn't find misunderstandings in variable types and what kind of data you're dealing with and a whole host of other things. Now, one way around that is modern development languages, because they don't care so much about variable types. That's a temporary fix. It doesn't work very well, and it doesn't work at all at scale. Like once you start getting into different typing algorithms in the back end and different memory management algorithms in the back end, you run into all kinds of other problems later down the line. And you're sacrificing performance to a ridiculous, like you would not believe how much slower it is to write the same code in Java that you could write in C in fewer lines of C. That actually happens. Java's a pig. That's not the only language that problem. Some languages don't have that problem, but they have other similar problems. Your integration is happening distributed across the group. Unfortunately, integration is a centralization problem. And so the only integrated thing is a centralized thing. Distributed things cannot be integrated by definition. Definitionally not possible. So you end up integrating code very quickly at the code level, but that doesn't integrate functionality, and it doesn't test running functionality. So then what happens is you get closer and closer to production quality in your development environment, but you're still removed from the production data, typically, although some people try to fix that. That's a mistake too, by the way, because your people who run your production system run it in ways that you as developers do not understand. Every company I've ever been at, every project I've ever worked on. And developers bitch about this when they find bugs that, oh, the customer shouldn't be using it that way. No, you need to learn how to code. That's the case. If you enable the feature and the customer is using that feature in a way you didn't expect, you don't understand the feature, you don't understand the use case, or you're just a bad software engineer. You should know everything your software does. And you should know all the possible ways it's going to be used and mitigate all the possible problems that would come from the misuse of that software. Full stop. Otherwise, you're a bad software engineer. Period. Sorry. You just are. And maybe you're not a software engineer. Maybe you're a coder, which is fine. Or maybe you're a programmer, which is fine. Or maybe you're like a good script person. All fine. But you would be a bad software engineer if you didn't account for these things. So at the same time, we're compressing the release cycle down so that we're getting closer and closer to development equals production. We're moving the integration process, right? Because half the integration is being done in the code when the code gets merged. But that doesn't fix the problem of integrating the data types and data flow and all of that stuff. So that's getting missed usually. Now, some of that can be mitigated by doing automated integration testing, where you have a QA environment and it's actually running to make sure that blocks of code are interfacing correctly without running the full app. And then, of course, there's all the running of the full app. Now, we've also compressed the testing cycle. So no one does integration testing anymore. Really, they should, or at least they don't do a full suite. They're relying on unit tests. Unit tests are bottom-up tests on non-running code because they happen at compile time, which means they can't find runtime bugs. Cannot. They can prevent runtime errors. They can't find runtime bugs. Unit tests can never find a runtime bug because runtime bugs are either data, integration, or code bugs. Code bugs come in many flavors. One of those flavors is integration bugs, which can't be found on non-running code because they're about the integration, the speaking of the two types of functions or methods or interfaces or blocks of code or whatever. or even pieces of software if you're running all APIs. So all of these things are being compressed, and the cycle is being reduced to develop and release. Now, I would call it develop and deploy, although Netflix does develop and release because they go straight to production. Anything that's not to production for me is not a release. As a release engineer, I can tell you confusing deployment and release is a mistake. It's an error in thinking. Because we're getting closer and closer to code release, the way Netflix allegedly does it, which is not the way they do it, by the way. But that's what they say. Some of them not. Some of them don't lie about it. We have compressed this cycle, but the complexity of integration remains. So your integration is now happening at your production. It's the first time your software is being integrated. But you can't find integration bugs in production without introducing bugs into production. So it's an error in thought to think that this is a good idea. To speed releases into production is just an error, because the only way you're going to find the errors is now in production. You don't have a pipeline to find errors in. So the minimum allowable pipeline for almost every situation, although I did find one a couple of years, 3 years ago now, that wasn't like this. The minimum number of stages is development, QA, production. And almost everybody should have a stage, and almost everybody should have multiple development environments. So if you're going to use cloud development environments, don't use cloud for production. Cloud's massively expensive. It's 3 to 5 times the cost in production as it is to just build it yourself. Literally, lease your own servers in 5 or 10 data centers. You will save so much money you won't even imagine. You cannot imagine how much money you would save by not running production in something like AWS or even Oracle, which is about half the price. I forget how expensive Microsoft is nowadays, but it's still massively expensive. All the software and all the cloud providers is open source, every single piece of it, literally. They've made some changes. If you have a good software team, you can make them yourself. You probably don't need them though, honestly. You could deploy your own cloud infrastructure services by yourself on your own as a small team without a problem, save your company massive amounts of money. This pattern of compressing everything down and making it super, quote, efficient, optimized, however you want to frame it, is the process of compressing and flattening the world. And now we see that flattening everywhere. Everything's getting flattened down because science and engineering, and now I have to blame engineering, unfortunately, being an engineer, very sad, and being a lover of science, also very sad to see the destruction of it in my lifetime. These things are focusing on efficiencies, but they don't care about what they're making efficient. Because efficiency is a trade-off. You can only make 1 or 2 things efficient relative to a bunch of other things which you make less efficient. Always. That always happens. You run into a problem, and that is the problem. The problem is science and engineering can tell you how to save money, making the release process more efficient in terms of time to market, okay, but not quality to market. Notice quality. If you want quality software in a release process, it's very simple. I used to tell clients this all the time. The process of release is a management decision between meeting a date, right, and meeting a level of quality. So either you want software of a certain quality, in which case the date that you set, you're almost never going to hit, ever. Because software teams are terrible at estimating the time to develop. Terrible at it. Absolutely atrocious. That's why things like Agile use relative measures, because relative measures are never wrong, effectively. They get adjusted over time. And so basically, you move back your software development team to the lowest common denominator or the worst case scenario. That's what happens with all relative measures of that nature. There's a little bit of variance in there. There are some exceptions to the rule, but there's no standard to be held to in a relative system by definition, and so standards are not held to, and so people get lazy. because work is hard, and I don't blame them. Work is hard, and work sucks to work. That process is more flattening. It's more compression. The software quality has to go down in that case, although Agile can produce higher quality software, but that involves paying attention to teams. If you just want to make dates, and something like Agile, you make every date, right? But what you do is you slip features and you slip bugs and you get tech debt, right? So you're trying to squeeze out the complexity of integration, and it's either coming out as tech debt, lost features, right? Usually also go into tech debt, lost opportunities to fix bugs, and you can't measure how good your team is because it's a relative measure. You can't even measure how good they are to another team because they're all using different relative measures. There are ways to kind of get around this, sort of, but they're terrible. Release needs to be a decision between making a date or making a quality product. It can't be any other way. And there's nothing wrong with that. But when you fail to do that, you either get lots of crappy product released exactly on time so the development team can reach their milestones, or you get really good software and you miss all your dates, but your customers are happy. So it's up to you. And because we've compressed these things down and not paid attention to the trade-offs, and I have a video on trade-offs on navigating patterns, my better channel, because we fail to recognize the trade-offs, because we're doing that, because we're not acknowledging, efficient relative to what? Efficient at the cost of what? Because it's always a cost. We fail. We make bad software. We try to get away with unit testing only. It's terrible. It doesn't work. Our software is getting literally worse by the day at this point. I mean, there's so many bugs in YouTube now. It's like, boom, I don't even know what to do. My phone's giving me 2 notifications for every update to the YouTube site. They're identical. And it's giving me an additional notification that Chrome updated a website. Now, as far as I know, I don't have Chrome running on the phone. It must be running in the background. Thanks, Android. I don't know why it's telling me it updated our website, like Google's website, that updates several times a day, which it's been doing all day. Why nobody could predict that this was going to happen is beyond me before they released whatever change this was, whenever it went into place. Because as near as I can tell, it's a web change, because I didn't update anything on the phone. They could have enabled that change through, recently, but had the code in place before. People do that. That happens, but I don't know. I don't work for them. I would never work for them. I can't imagine what a hellish landscape their development process is, given the poor quality of their software. But it's not just software. We're flattening everything. We're flattening identity down from 5 or 6 or 10 or 12 things down to 1. The color of your skin, or how you vote, or which group you're a part of, right? That's the flattening of the world. And that takes away integration, just as in software. How do you integrate your different roles in life, your different responsibilities in life? Well, you don't. You're just a straight white male. There's nothing to integrate. So we're trying to do away with that, but you can't. All you can do is delay integration. Then it comes out as anger and resentment later, right? And even in software, it comes out as anger and resentment later. Trust me, right? We're trying to compress things that aren't compressible, and we end up moving complexity around, because past a certain point, you can't make things less complex. The complexity just gets moved around. Do you pay for it now? Or do you pay for it later? When in the process are you paying for what? If you pay late, can you recover as easily as if you pay early? Better question. I've never seen a situation where paying early wasn't better than paying late. You get this concept in investment. Be ready to pivot. What do you think pivot is? Changing your mind, admitting you made a mistake, and taking a different route. Release early and often so that you can find errors. Well, deploy early and often and have a good test environment so you can find errors quickly. Yeah, I mean, it's all right there. And it's not just software, although it happened in the software industry years ago. And it's gotten worse for sure. But I'm seeing the flattening everywhere. What are you seeing?